Hi, good afternoon, it's Gene from maverickstar Observatory. As you know, it's the 18th of January 2021 and it is also that point of the month when we break out the SD cards from the Trimag and the magnetosphere sensor and plot that on Google Map as to show us where we are at the current time with regards to where the magnetic North Pole is. So bear with us in this upload and we'll get to that shortly. As you can see though, before we go there, and this is due to be updated because it only runs up to 2018, you know, over the last 30 years we can see that the magnetic North Pole has migrated a double in distance, covering more land in shorter space of time than what it did from the 1900s when it first started to migrate till 1990. So in the last 30 years, not only have we seen over 1,000 miles of migration of the magnetic North Pole, indicating it has increased in speed more than once, we also see it's covering more distance, and that means we're getting close to something happening. When we look at the recent data that, as you can see here, from the 17th of the 12th 2020 to the 18th of the 1st 2021, it doesn't appear like there's a lot of movement. 4.2 miles doesn't really show up very well on these graphs. But nevertheless, the way all this was configured was to no doubt show a movement in the magnetic North Pole as it did move. And you know, when you're looking at these charts, you might not see anything at first glance from one month to the next. But if you just go back into the archive, you can see it's hovering now more over 13 degrees on the left hand column than what it ever has done. If we just go back into the archive, you'll see that when we first calibrated and started running the Trimag system, we go back down here, you'll see it's all virtually at around 10 and a half, 11 degrees. So you know, there's been a lot of recordings over every month since then. You know, we've got a good archive. We know that the magnetic North Pole is migrating and our equipment is working as it should. The other thing is what I'm scheduling either this month or the beginning of next month is to do a bit of service on the equipment, because it's been running now, touch wood, really well for the last 2 years without any maintenance, hardly ever. We've had to replace one of the transceivers on there that transmits the data from the actual Trimag tube, one of the 3 tubes, to the master. I think it was on track 3 that we had to replace it. But what I want to do is just replace all the power packs, you know, give the circuit boards a good cleaning and just make sure everything is running the way it should be, even though it is. You know, I don't think maintenance is a bad thing. I wouldn't want the power packs to start failing now, so you know what I'm thinking about doing is replacing those power packs. Not really expensive equipment, but I think if we keep it all maintained just like we do our cars, you know, you put a new oil filter, new engine oil in there, and it keeps it running sweet for you. I think that's what we should be doing here, as we've had no trouble really for the last 2 years. So let's put this into context then. Let's have a look on Google Earth and see how far the magnetic North Pole has migrated and where it is with regards to the longitude and latitude. Okay, so the latest magnetic North Pole is, as you can see, latitude 83 degrees by 21 hours 28 minutes 14 seconds north. Longitude is 123 degrees by 53 hours 1 minute 46 seconds east. It's migrated around about 4.2 miles, and we'll just have a look at where that is in perspective to you know, where we're travelling with all this now. You know, the heading is still moving east. We'll just zoom out. You can see all the recent pin marks that we've put in on the Google map. You can see where it is in conjunction to the corridor in which it's moving between the white and yellow lines, and you can see how far we are off from that all-important 42 degrees, which is around about 2.5 years now away. And if we just zoom out a little bit more, we'll see where it's heading. Straight for our pin mark, just south of the equator, sorry, south of the Arctic Circle, almost central Russia. So, still on its way there. We know why it's migrating. We know that it's because the intensity over Russia right now is increasing, and as a result of the intensity over Canada decreasing, that's why the magnetic poles started to migrate in the first place, and move towards its new North Pole position. I don't expect it to stay even there when it arrives. I know from what we're seeing right now, the intensity where that pin mark is increased, but you know, I think it's just good to see over the last 120 years where it's migrated from Canada to its current position now, almost over the North Atlantic Ridge at its current time and position, and still, as we see, tracking towards Russia, or central Russia, just below the Arctic Circle. Now, I know it's really easy to take things for granted, but we have worked really hard over the last few years, especially in trying to put together the pieces of the jigsaw puzzle to bring out a trend. And using the scientific method, using equipment to do that, we're probably the only ones on YouTube, certainly on YouTube, on any other platform, and from any other organisation, showing you what you are looking at right now. And we have worked out a few things. We worked out why the poles started to migrate in the first place, and that was because if we look at the top left hand chart, we can see temperatures. Over on the right hand chart we can see intensities, and on the bottom chart left we can see swarms data emission, showing the intensities in these plumes that are merging over the continents. We know first of all why the poles started to migrate, because Canada's intensity, as you can see on the bottom left and on the top right, the intensity has started to weaken, and it has increased in Russia, and that is why the poles have started to migrate over towards Russia. We also, through using not just the TriMag system to track it, and using other data from other departments where we can see where they've mapped the intensity field lines around these epicenters, we've also used recently, last year, our muon detectors to work out whether, you know, in these high intensities they get more protection from cosmic rays than they do in the low protected areas. Now, we haven't got nothing in Brazil at the moment, but we have got something in the UK. And if you look at the top left hand and the bottom left hand side charts, you'll see that not only is it warmer climates around England, it is also in between two high intensities of Canada and Russia, and as a result of that we get less protection. Now, our muon detectors showed us that, and we could confirm it with the muon detector we've got over in Perth, Australia, because Perth, Australia had, to the top of my knowledge, off the top of my head, we did do it a couple of days ago, I think it was around 157 muons per square metre per hour, compared to over here in the UK where we've got less intensity and less protection, around average of 500 muons per square metre per hour. You know, we was able to figure this out and not just use guesswork based on the scientific method of using equipment that we've got, and put it together to show you guys. So we know now for a fact, and this isn't the first set of data that we've had from Perth, Australia, this is the second one we've had now which has showed consistent low numbers, and that is in a region where, as you can see on the bottom left hand chart, in a region of high intensity, probably about 60,000 nanoteslas or 60,000 microteslas or 60 nanoteslas. So we know a few things. We know where the pole's heading at the moment. We know in the stronger regions of the magnetic intensities, these are the regions that are coldest on our Earth. It's no coincidence when we look at the top left-hand chart and compare it to swarm data on the bottom left, that we see that not only are these the high intensity regions, but they're also the lowest recorded temperature regions on our planet. I just want to say something. You know that over in Russia the intensity is increasing, and therefore it should come as no surprise that over the last few days Russia have reported coldest temperatures on record. China has reported coldest temperatures on record. Spain likewise minus 34 degrees over the recent days, and we've got over in Siberia deserts filled with ice. It is no coincidence that we've got this taking place in our world. It is because the ever increasing intensity of magnetism building up in Russia just below the Arctic Circle. Russia is going to get colder. It is predicted that Canada may see a little change in favour of it being moderately warmer. We're talking probably 5 degrees on some days, warmer than it would normally be, and that is going to be really hard for us to pinpoint. I think the best thing for us to do is not just set up magnetometers in Canada, but also maybe at a later date, if we could encourage one of our superstars over there, Kendall, to take on board a muon detector and maybe a temperature station, so we can keep a record from now on of temperatures in these regions, as well as muons, as well as intensity. The more thorough we do our job here at the observatory, the more information we get, the clearer the data becomes, and the clearer the information becomes, and we can make further predictions based on that data. So we're doing a great job. That's the bottom line of it. It is a little bit sad that we've seen a little bit of a reduction in the support that we get, despite everything now coming together and us being closer ever to that 40-degree mark that we see on the Google chart map, where we're putting our pins in for you to follow as well if you want. But the work is by all means not over, and if we can get a few more people to step forward, support our efforts here at the observatory and keeping people more informed, we could be looking at better data and more clearer examples in the future. And I'm sure that it is important to us all now more than ever for us to all come together, pool our resources and do that. Just because I mentioned the temperatures declining over Russia, China, in Spain, over the Sahara Desert, doesn't mean that that's the only case of things happening. We've had over the last 30 years dramatic changes to our jet streams, which is causing big trouble with regards to crop production. It's making it harder for farmers to get their crops in the ground and out the ground, and continue to bring out the ground the yields that they are used to. At the end of the day, we are feeding more people on this earth than we ever have done in the history of mankind, simply because we're at a situation where there are over 7 billion souls on our planet, and one of the requirements of those people is food, as you would expect. But if at the same time we are seeing dramatic changes with millions of hectares of land not being able to be used for agriculture, then it's no surprise, is it, that there are some organisations and some multi-millionaire companies getting together to see if they can produce alternative foods, such as maggot larvae, or introducing into the food chains things like crickets and things, things like that, locusts. I'm pretty sure none of us want to go down that road in the future, and I'm pretty sure that it's important for everybody to get a good clear idea of how this world is changing, because we need to change along with it. We're not a rigid part of this system of nature on our planet. We have to be fluid, and one of the things that has surprised me is that there is no allowable freedom of movement, especially right now with COVID-19 stopping us all travelling around the world in order to try and contain this. Now, whether you feel COVID-19 is real or not is another question for another debate. I'm just trying to stick to the facts. One of the things I can see happening as a result of this pandemic that we're all in is that people are getting used to working now from home. And the big thing here is, I can see in the future happening, is an exodus from cities, because if you don't need to go to your place of employment to work, and you can do it from home. I know it's impossible for a lot of people when they're involved in manufacturing, because obviously they need to be in the factory to manufacture, but for a lot of service-based industries like we have in the West at the moment, it is plausible for us to work from home quite easily. And, we might not be going back to the office in the future because the company might see the benefits of actually having people work from home, and therefore, it saves that company paying rates on and rent on buildings that they don't really necessarily need if people can work from home. But the thing I was thinking about is that if people don't need to work in their offices and things like that, then they don't need to be in the city. And for that reason, I can see a mass exodus of people leaving their place of residence in the cities because they don't need to be close to their place of work, and moving out into more rural areas. And that's not a bad thing, especially if at the same time of leaving the city you can actually pick up a nice reasonably priced property with a bit of land with it, so you can get your own garden growing of food and veg. So that's where I can see one of the things in the short distance taking place in the future, as well as a progressive decrease in global temperatures. We could be quite easily slipping back into a glacial period on the back of this pole reversal. If that is the case, it's going to change our ways of life permanently for the long-term foreseeable future. I'm sure that we have already had the best of our north and western weather already, and that things are from this point on going to continually get worse. Now, how long, you might say, how long we got before things get better? Well, it's been over 30 years since the climate has really started to worsen on the planet with regards to the the mutated jet streams that we're now experiencing. And it's at the same time we see the greatest migration of the magnetic North Pole as well in the last 30 years. So that's what we're looking at. Things continuously getting worse until they start to get better. Now, we've not reached 40-degree mark. We don't know when we do enter the weak field lines how long it takes for that reversal, but the pole is likely to end up somewhere close to Australia, the North Pole, and for another 120, 130 years it will slowly migrate probably back down onto the Arctic Peninsula, where it settles down for hundreds of thousands of years, hopefully from that point on, if we are talking about a completed magnetic reversal, which is 500,000 years overdue. So that's what we're looking at. So just to put that into context, it took 120 years for it to get where it is right now. We're getting close to the 40-degree mark, where it will leave the strong field lines, go into the weak field lines, migrate fast. Hopefully within a period of weeks we should be able to see go somewhere close to Australia Peninsula, and then at that point another 120 years for it to circle back over the Arctic Peninsula. And then when it does go to Australia, perhaps another 20-30 years before the weather starts to improve, and then another 100 years for it to get into the Arctic region. So the new North Pole probably will be somewhere in the Antarctic region, and from there on we should get more stabilised weather as the magnetosphere hopefully comes back up to its full strength. But during that period of time, could be weeks, could be months, where it leaves the strong field lines, we will experience a massive reduction in the magnetosphere, and at that point we can expect massive changes in our climate on this earth as a result of that. So I think that there is a good reason for people to store food at least for probably 5 years. I know that's not easy for a lot of people, but that probably is a good idea to do that, because during that period of 5 years where it enters the weak field lines and starts to make its way down the North Pole to Australia, we are going to be experiencing probably climates where we are not able to manufacture and produce food at the rate we have been currently, even though right now things are under a lot of tension. So that's really what we're looking at, and that's what we've been able to gather through the study of what we've been doing here at the observatory. So that really is the forecast for now, based on what information we have at hand and have collected. So I know it's not cheerful news. I know we do try and remain optimistic, but just giving you a heads up as to what to possibly expect. And this is based pretty much on a lot of logic and, you know, the data that we've collected to date. So, you know, there's no real reason to go on anymore, guys. I know that you've got other things to do in your lives. If I can just mention the link down there, or on the website where you can make a donation and help support what we do here at the observatory, you know, it'd be greatly appreciated. The only other thing to say is take care of your loved ones and start making those preparations for the future. As always, bye for now.